No it don't! No it don't!
So the question now is, how do you apply calculus to real life problem? Because everyone asks Mr. How do you actually use this in real life to real situations?
Is this the equivalent of related grades?
It is. How do you apply this to real situations? Here's how it works. And this is actually for all of you who are planning to go business and open up your own major factory and become a billionaire. This is for you guys, okay? I'll start with a classic example. I have a challenge for you. I am a farmer. I have... Farmers make a lot of money. Do you know how much things make for selling blueberries? They make like $2 a pound these days. It's real money. So here's how it works. Scenario. I'm just going to start off with a little scenario for us. Scenario. If I want a farmer, I have a bunch of chickens running around my farm. And what I want to do is I want to build a fence. Okay, scenario. I have exactly 150 meters of fencing. Okay. You have 150 fencing to build a rectangular fence. Most fences are rectangular fence. My question to you is this. Find the dimension that will give max area. That will give max area. I want you to play around with it and just see if you can find it on your own, just using guess and test method. So what I really have, so let's draw your fence and draw a bunch of chickens running around. There's my chicken running around. Sorry? A top hat? There's my chicken running around. My question is this. What should the width and length be such that I will have max area? Because I want to maximize area with using the lowest amount of material. Question is, what should the sides be? Let's see if you can figure out the most. Go. So, I have, my first guess was, Mr. I'm going to guess area. I can create one that's 1250 square meters. Can anyone beat that? 1400? 1406? What's your area that gives me 1406? So what's your dimension? Nope, 1406.
40 and 35 gives me 1400.
1400?
Yeah, when you go 40 multiplied.
Okay, so this is 40 and what's the other one?
35.
35? Can anyone beat 1400 square meters? 1500? 5400? 5000? How do you get 5000? So what's your dimension going to be?
No, 40.
So far the record is 14. It has to be 150, yep.
37.6 and 37.4.
37.6?
You can't go higher than or lower than.
So give me 1 second. 37.6, 37.4. Now the question is, okay, does that give me 150 dead on? Now what's the area of that going to be? 1406. Can anyone beat 1406? 0.25? So if I look at this thing, now this becomes a game. See, I say, what if I move this up but I shrink this down? How does that affect the area? I can sit here.
Wait, 35 multiplied by 40 gives you
1600?
No, never mind. No.
So I can sit here all day and try to play with this. And half time when you build a fence, I guarantee you this, your mom and dad builds a fence, they just build a fence without actually doing calculation. You actually lose a lot of space like that. I'm going to show you how to use calculus. in order for you to do calculus this, you can always create two equations. To solve optimization problems, you will need to create two equations. You will need to create two equations. Two equations. The first one is called your maximized equation. Max-min equation. I'm going to show you what this is in a second. The second one is called your constraint. Every question should have two. I'm going to start with the first max-min. I look at my question again, and it says this. Find the dimension that will give max area. See? I'm looking for max area. So right off the bat, I want to create an equation that involves area. So what is the equation? So let's draw this again without numbers. I don't know anything about the sides, so I'm just going to call this x, and I'm going to call this y. Create an equation for the max area, because that's what I want, see? Max area, using x and y. Samuel, what is it?
X multiplied by y.
X, y equals to a, because that's the formula for area. Constraint is a second equation that says what limits you in this one. And if I look at my question, the thing that limits me is this. I have 150 meters of fencing. This is called my constraint.
2x plus 2y.
Yep. So if you look at this one, somebody say, hey, I'm starting to get the hang of this. 2x plus 2y equals to 150. Okay? Easy. But the problem is I have two equations. I can't work with two equations. I can only work with one. So what I'm going to do is I'm going to merge these two together. Merge your equations together. Equations together. You may do this by substitution, or you can use any other method you want. But in this case, I can use substitution. Some of you ask me, so which one do I merge with what one? I'm looking for max and min. So this is my main equation I'm going to work with. So you don't touch that one. This is the one you're going to work in the end with. So solve for either x or y. Doesn't matter what it is, guys. And sub into your max min equation. Go. I'm going to personally solve for x. Makes no difference what you solve for. So what? Because I'm going to go 2x equals to 150 minus 2y. X equals to 75 minus y. See, that's done. Once I have this, I can actually sub it into my main equation, which is my max and min equation. And I go A equals to 75 minus y times y. Okay. That gives me A equals to 75y minus y squared. And in this case, there's no such thing as time. It's very similar to related rates, but now what I'm going to do is I'm talking about max and min. So when I talk about max and min, I need to know my CP, find my critical point. Because max and min really refers to the critical point. So what is the critical point of this equation? Take a minute, find the critical point for me. Go. I'm going to pause it. And according to your time, you're just doing it to take the derivative with respect to whatever this is. Because this is not a time question. So now I go A prime equals to 75 minus 2y. If I did this correctly, I have 2y equals to 75. Y equals to 37.5. Now the question is rigged. I'm telling you this right now. If I'm asking about max, what you get here, normally you're gonna do your line stuff, dude. You're gonna go ahead and do your line thing. You have 37.5 right here. Every question is rigged. I'm telling you right now it's rigged, such that if I'm looking for the max, see, it says find max area. This will automatically be the max. If you don't believe me, go ahead and test the regions out. If I test my regions out, you should have an increase here and a decrease here. It's automatic rigged, so it just always works out like that. So right off the bat, I know that max occurs when y equals to 37.5 meters. Okay, that's my maximum. So if I set my y to be 37.5, I will get the maximum value possible. But I'm asking for dimension. So now, go back and find x for me, please. What is x? To find x, I know that my formula was 2x plus 2y equals to 150. So let's sub it in. 2x plus 2 times 37.5 equals to 150. Solve for x. A rectangle is also a square. Yep. So x, I believe, is also 37.5. If you don't believe me, let's see if my area beat out on your area. 37.5, 37.5. Punch it in. Let's see if I beat your area. It is. A rectangle is also a square. A square is a type of rectangle, really. So 37.5 times 37.5. So really, I beat your area by 0.25. So all you guys combine, but one little math thing proved you wrong. So your guess, yeah, that's a potato. So your guess was 1406. I beat you out by 0.25.
Did it please say 37.5?
30, you have to go 37.5. So that is the power of calculus, guys.
Mr. Laura, is that Hindi? I don't understand a word of it. Do you get it?
X's and Y's, right?
X's and Y's. So that is what power calculus does. Because a lot of people say, so how do you use calculus in real life? That is how. Now, in the business, listen, écoutez. In the business world, if you make one little error that's off by 1 centimeter, that can cost you millions of dollars. I kid you not. So what they do is they hire mathematicians. When they build a factory, they hire mathematicians and engineers to calculate what is the best value so that you have the largest possible volume using the least amount of material. Try this question. I want you to grab your package, turn to this, and I have more this time. But what if I change it up a bit? Look at example 2. This time, I'm cheap. I figured, why build a 4-sided rectangle when I can use a river? Because if a chicken runs in river, it's no longer walk-in. So I use this river as the 4th side. The question is, how? Try example 2, guys. So how does this change the whole dynamic if I change one variable of this? Example 2. So now I upped your ante a bit, and it says you have 2,400 feet of fencing. You're going to use the river as your 4th side. How does that change everything? Good luck. And I'll pause my recording. How does one little thing change a graph? Now, if I look at this, I'm going to use the side as a river. So really, if I have a chicken here and the chicken goes to the river, well, yeah, one less chicken to worry about. So there's my chicken. So the only thing that changes now, my area, see, notice I'm looking for largest area. So my max min formula for that really is x times y again. That's x and that's y. The only thing that changes is my constraint. I have 2,400 equals to, notice there's going to be 2y plus x this time. Because one side is missing. So my formula really becomes x equals to 2,400 minus 2y. There's my formula. I plug it in. A equals to 2,400 minus 2y times y. And if I did this correctly, I have 2,400 y minus 2y squared. I'm going to take the derivative of that. And I believe I should have y equals to 600? Yes, that is correct. 600. Now, some of you say must know, is my x and y mixed up? Does it matter? The answer is no. I just use different variables. Okay? So as long as you have 600 and 1200, it's fine. Because it doesn't matter about which one's x, which one's y. So that will give me the largest possible area ever. That is how we do that. And I'm going to pause my recording here. I'm going to assign